2014.
Is that one?
No.
No, that's.
This is relatively new. Agree? 2014?
Yeah.
It's the first one I pulled up. So, if I can make it a little bigger.
So if you go to drop down, it'll give you like sizes. Or those 100.
You guys can see it though, right? It's just me that can't.
Yeah.
Wait, so how many questions on like the?
No, this is a drop down. The 1 and 3, just drop it down and just pick it up. You can go bigger.
Alright. Okay, so, good job. So here we are. The first two questions have to do with normal distribution, which is what we've learned, okay?
Yeah.
So I want to look at number 1, okay, and I want to kind of talk about it, and I want to show you how it is solved. The problem is we only are together one day this week, maybe 2, I'm not 100% sure. So the idea is that we can cram as much of this in while reviewing for the rest of the test. Because next week, God love you, God love me, I don't even know where I'll be. So the petrol, which means oil by the way, people get nervous, consumption, by the way your room is really good, I have one, of a certain type of car has a normal distribution. Okay, so what is the normal distribution? How do we set that up to make it so I know it's a normal distribution? Yes.
P squiggly
Isn't that just
and
yeah? These were the
is it P squiggly and
P.
Let's go to 9.
It's X.
Or is it N squiggle or
it's P squiggly and
Or X.
and then in parentheses
Right.
the mean so the
And the
mean,
variance.
The mean
How to do it.
and then the variance. Okay, so let's look. The petrol consumption of a certain type of car is normally distribution with a mean. So the first thing is mean, 24. Okay, per liter, and a standard deviation. What I'm giving you to do.
4?
Is that what?
Yeah.
It's really nice of me.
And there's like a whole tutorial. Like,
Exactly,
that's so
on
cool.
how to do every single problem.
That's
So
really
that's
cool.
my goal is for you. Okay, with a standard deviation of 4.7.
Yeah.
So what goes here?
The square root.
4.7 squared.
Exactly, 4.7 squared.
We don't.
Did everybody write that down?
it's much easier.
Yeah.
Did everybody do that on their own?
I did.
Yes.
Can you explain what square?
That's the formula,
Because it's the
which I
variance.
gave you last week.
We don't care about the variance.
Because it wants the variance and the variance is equal to
Okay.
the
Right.
I was confused because I thought it was like this. The standard derivative was like squared, but I know that the variance is standard. You know what I'm saying? I know what I'm
Do
saying.
you know what you're saying? Okay.
Why are we putting the variance in there if we don't care?
The formula is variance. I don't know
That
why.
makes no sense.
I know.
Wait, Miss Kid, these aren't on this sheet still, right?
That is correct. This is 2014. Test
No,
2000.
I meant the like
The
variance and
No, not on there. I don't know. So here's what I want to do. I want to attack as many of these as possible. And then my game plan is to take one 2016 test and put it on Edline so you guys can print it out and actually do a test for a test grade, like a review. Okay? So there's a whole lot of take-home tests, bring it back, and you get good grades coming up. So let's just, bear with me. Because I told you at the beginning of the year, this time of year, it's just, it's not me. Okay. Find the probability that the oil consumption of a randomly chosen car is between 21.6 kilometers and 28.7 kilometers per liter. So how do I write that? Yes.
How do you, you do 21.6 is
The probability.
probability of 21.6 is less than X is less than 28.7.
Okay, now, in the real world, this is real world information. Because the real world has infinitely amount of numbers, right? We don't have a chart with an infinite amount of numbers. So we actually have to convert them to z-scores. These will not be located in your chart, okay? You actually have to convert them to z-scores. Once you convert them to z-scores, then you can find their probabilities. Yes?
Why did you square 4.7?
It's the formula. It's the mean and variance. Yeah.
So this is like raw data, but we convert it to the z. We're converting the z scores, and then we look on the table to find the probability.
Right. And sometimes you're given the probability, so you look in the meat of the chart, sometimes you're given the z-score or x to convert to z-score, and then you look for the probability. So there's two types of problems
X
here.
and Z are the same thing in this formula.
Right.
Okay, I just want to make sure.
But it just did it a different form.
Right. So now I have to convert 21.6 to a z-score. I also have to convert 28.7 to a z-score. A z-score has a formula. It is x minus mu over standard deviation. Is that given? No.
Great.
Sorry.
Z equals X minus mu over standard.
In this case, yeah. Okay, so let's talk a little bit about what everything is, okay? Do you guys agree? This is mean.
Yes.
Do you guys agree? If I 4.7 squared is a variance, right?
Uh-huh.
But what's the mean of it? I mean the
4.7.
4.7 is a standard deviation. Sorry, I was having a hard time. And then in this case, my x is here, and my x is different here. So I have two different ones. So literally, I would take this and I would write it as a little formula. I would have 21.6 minus 24 over 4.7 is less than z, correct? Because we're
Okay.
moving to z-scores. Is less than 28.7 minus 24 over 4.7, close parenthesis. Now I have math magic to do.
Is it okay if it's negative? Because the first one's negative.
That's okay. Okay, so tell me what you get here. Negative
Negative 0.51 and then 1.
0.51, give me 4 decimals out. 5106
Oh, 6, yes.
0.06.
is less than z is, and then what's the other one?
1.
Right, just plain out 1. Okay. Sweating, sorry. I've been having, you don't want to know this on film, hot flashes.
Oh, it's on film now.
I'm dying. And I don't know if it's my sugar. I'm really out of
You wore
sorts.
pants today.
I wore pants today. Normally I come in my underwear, right?
I meant long pants.
Yeah.
That's on film.
It's on film. I really need to stop, don't I? While I'm ahead. Yeah, I wore pants.
I like your pants though.
Thank you. They're really
In comparison
comfortable.
to the underwear.
They're very comfortable. Yeah, you don't want to see those. All right, now, so here's the dilemma. See, now it's getting cool in here. Gosh, it's been a rough week. So, do you agree that this is my almost perfect normal curve? I'm so excited. I'm going to keep this one up.
Yeah.
So here is my z-score 0, my center, right? And then this is 1 standard deviation. This is 2 standard deviations. This is 3, right?
Right.
Moving backwards, -1, -2, and -3. So far, so good?
Mm-hmm.
Okay, I gave you some insight. The only way that you can find probability on that table is when you come to the right of the mean, behind it. So, for example, at 1, everything behind it. Do you agree with me there? Right? Okay. I cannot start here and work behind it. I have to find its mirror image that matches it. So, for example, negative 5.5, having issues.
0.51.
Yeah, okay. So where do I find that? Where does that happen?
In between 0 and 1.
Yeah.
0 and -1.
Okay. In between 0 and 1.
-1.
So I know it's in here, but I have to actually, because I'm looking for the things that are greater than. How in the world, let's kind of look at what's happening. I'm looking to find the stuff from here to here,
Which really all of that.
It's points.
right? So I'm
Oh,
looking for the
1 to
stuff in
1.
between.
Right, you don't separate, like, you don't look for, like, between -1 and 0, and then from 0 to 1, right? You do
Right,
the
you
whole
have to
thing.
look at that whole thing.
Okay.
Okay, yes.
So you want to find the 1 for 1 and then subtract the things that are less than the negative 0.5.
Mhm.
You need to do a mirror image thing
Yeah.
Right.
like that.
Let me show you how it looks. That way I'm not recreating the wheel because it's right here in front of me. Do you see it? Okay. Ugh, this bar. Okay, so this is what you see on your paper as of right now, correct? Okay? We know what we're looking for. We're looking for the items in between, okay? You just said in words, we need to find the things that are less than 1 first. So where would that be? That would be from here all the way back.
Yes.
Correct? then you subtract the things that are less than here,
And we'll be left with that.
and you'll be left with that. Does everybody see what happened there?
Mhm.
Yes or no? So from here back minus from here here. So how does that happen? Well, from here back, we're good to go. We can find that
Mhm.
because it's to the right of the mean backwards. So we're good to go. Let's look at our little chart for a moment. Look for 1.0 because that's what it is. And what do you get? So you're going to start down the left-hand column at 1.0 and move your up to 0 because it's 1.00. And then where do those two things meet is that point. And you should get 0.8413.
1.0.
So 1.0.
0.8413.
Right. So from here back, it's 0.8413. Does everybody understand that?
Yeah.
From here all the way back, but we don't want this piece. From here back, it's 0.8413.
Mhm.
But what we have to do is we actually have to get rid of from here back. I cannot find it from here back. How does that happen? I have to find its mirror image. And where would its mirror image be? It would be over on this side, right? And from that back. So how does that look? Well, it's 1 minus the probability of z is less than positive 0.5106. Yes.
How is that a mirror image? So so you got the negative 0.5106 going back from there, and that's a mirror image of the positive.
0.06 going
Could you draw
up.
it?
Can I draw it? So, okay, so, not so pretty. So you understand negative 0.5106 is here, yeah?
Mhm.
And we cannot find that. That's a big no-no, right? So what we have to do is we actually have to find its positive, 0.5106, right? But what you're trying to find, would you agree with me, is you're trying to find this to the tail. So
Uh-huh.
literally, you're trying to find this to the tail,
Yes.
because they are the same. So if I find 100%, one whole, minus this to the tail, right? What do I have left? The other side, right? So that's what's happening here. So I have 1 minus the z is less than 0.5016.
So I have a question.
But okay, let me talk for 2 seconds, okay? So I can't do this to the tail. Would you agree with me? So what do I have to do otherwise? I have to find here back, right? What is this back, amount-wise? Okay, how would I know how that all works? You know that this whole thing adds up to one whole, 100%, right?
Yeah.
So what is 100% one whole minus 0.5106? What do you get?
0.3047.
What do you get?
3047.
0.3047? No, that's not what.
0.489.
Yeah, you have to.
Yeah.
So that's the z-score, not the
You have to find, right,
percentage.
right, that's the problem. Yeah, so you have to take z is less than 0.5106, 1 minus that, and that gives you 0.695. Please look up, yeah, you see where I am?
0.5106.
Yeah. You with me now? Are you,
Yeah.
okay.
I'm getting 0.6950.
Oh,
Yeah, we're not
there's
getting
a-
the 3.
Well, it's, whatever. Now it's 0.
What-
Yeah, it did. So it's 1 minus that. So you end up with that minus 1 minus that.
That one minus that number is 0.3047.
Here,
Yeah,
that's what we're looking for. 0.3040,
047.
0.3047. And that's what you had told me a second ago. And so that minus that gives you your actual answer. Okay, so Kalia, what's your question?
Okay, so you found the z-score from 0.1, wait, 0.5106, so what you found for the z-score?
Yeah, and what do you get there? How do you do that?
And you found on the
Your little chart. You don't have a chart on you, right?
No, I have
You
one,
have
but
one.
it's not, it's
Okay,
not
gotcha,
on
gotcha.
right now.
Okay.
And then, so what is the 0.3047, what is that?
So that is the .84, it's from here to here is .8413, right? Minus from here to here, okay, which is .30407. That gives me this spot here, which is .537. Okay? So that's how that works. Fun stuff. Okay, now let's look at the next one. Okay. Lengths of a certain type of radish are normally with mean mu, and standard deviation sigma. Okay, so they're not telling me the mean and the standard deviation. 4% of these radishes are longer than 12 centimeters. Okay, 32% are longer than 9 centimeters. Find mu and sigma. This is a case where we actually are going to end up with two equations with two unknowns. Okay, you're going to be looking for mu and sigma. They're actually giving you the percentages. You end up finding the z-scores from it. Okay, so is that what made sense? So go ahead and write down what you have to write down, and I'm going to bring up the answer, the work scheme, and we'll go through it. Okay. So at this point, they're not giving me anything other than they're not telling me the standard deviation or the mu. Okay. So back here, number 2. Once we get it started, we can finish the problem here. Okay, I guess that's the whole thing. Okay, so let's take a look at what they do. Do you agree that for them to be a length larger than 12, it's 4%? Is that cool? So for them to be a length less than 12, it's 0.96%. Why would they do that? Well, let's look at the picture. So let's say 12 is here, right? For them to be greater than 12, right, it's 0.04%. Everybody cool with that? Can I measure from there forward? No. I have to measure from here backwards.
And do
Does
one
make
minus
sense?
that.
So I'm looking at, what's that? Go backwards, right? So from here backwards is the number that I need to look at, which is 0.96. So is everybody cool with that? So if I look at this, greater than 12.04, from here back is 0.96. Yes? Okay. Now, so I have to, what is the 1.751? We have to look at the z-table. We have to look at the percentage, which is in the heart of it. And you're looking for the z-score that corresponds to that.
0.96.
So the 0.96 is in the heart of the table. So you're looking in the heart of the table, and I can't see that with my glasses. So you're looking for something that's under you don't want to go over it. Does that make sense? So 0.9600 is really what you're kind of looking for.
So like 0.9.
Yeah. And so you're going to come over here. I can't read it.
It's 1.7.
And then, so you,
And 5.
We put it up there. So.
let me put it up on here for everybody. That might help. Okay, you see it? No.
I have this page.
Maybe we should turn off the light.
Yeah. I think a light one.
A light, another color. Does anybody have a different color? Blue.
I have a purple.
Pink,
That one's gonna be hard. I think the pink would probably be the
pink
easier
might be
one.
better. I don't know. I'm trying. You want to hit the lights real quick, Maddie? Oh.
I think the orange one's probably better.
Yeah, I think so.
Yeah, but there's a purple here.
Just picture the last one.
Something weird is happening with the lights.
Nope.
No.
Here.
I'm trying. Does anybody have a white one?
That will work
You
best.
printed the
I
color.
printed the colors for purposes. Okay, let's
That's
just
better.
say it
That's-
works.
There you go. You can actually see it.
Okay. Yeah.
Okay, now, so your goal is to look for 0.96. It can't go over, okay? So I'm looking in the heart of this thing here. Okay, so disregard the ugly nails, sorry. So I'm looking for, and you're gonna have to help me because I can't
Point oh,
keep
1.7. Keep going. Right there.
right there.
0.9.
So it's
Yeah.
0.5.
So it's
0.95.
0.9599, is that what that is?
Yeah.
So I'm gonna come straight across
1.7.
1.7. Does everybody see that?
Yeah.
And then I'm gonna go
1.75.
up this way to see which column it's in. I think it's in that column.
It's in 5.
You guys, I'm dying here because I can't see that. So you guys have, okay, so 1.75. So it's 1.7 and then over here, 5. Are we cool with that? The more table over here is when you have to add like 1.51 to the end of it. You add 2 to the percentage points at the end. It's a yeah. Okay, so let's go back to,
Okay.
so let's go back to this, okay? So, does everybody understand where the 1.751 comes from?
Yeah.
Why is it the 1?
It's
Because
from that extra table.
Yes.
oh no, but I thought it was just 5. Or was it 5?
Yeah, there's a second part, but it's confusing, so she's not gonna show us how to get it.
Oh, okay.
Do I need to?
You don't really need it.
So if you just put 1.75, would it be wrong?
I think it would be okay.
Okay.
Okay? So at 1.75, okay, so there we are. Now, so we keep in mind that my little formula is x minus mu, which we don't know, over sigma equals z-score, which is what we just found.
Yep.
All right, are we cool?
Well, why is there like a -1 in the, like when you start bringing it over to make it? Oh, it's circle.
This guy here, that
Yeah.
means problem number, that means, I'll show you. The way they, yeah.
Is it like 2 columns?
Yeah, we're gonna do two equations, see?
Oh, it's
number two.
equation 1, equation 1.
Right,
Okay.
right. Okay, so what they did here was they took the sigma and brought it over, because they're gonna solve 2 simultaneous equations.
System of equations,
Correct.
eliminate substitution.
Correct. Now, what did the second question say? Does anybody remember it?
It's like 32% for
32% are larger than 9%, 9 centimeters, right? So if I'm looking at this, does everybody agree 32% larger would be to the right of 9? Are we cool? Right? And so we can't do that, so we have to do the stuff behind it. So it's 1 minus that, so it's 68%. Okay, so what are we going to do? We're going to look in our little table at the 0.68. And what are you getting for your z-score? 0.468. Is everybody getting it? If you had those things, that'd be easier. Okay, so but does everybody, can you go home and like kind of practice that on your own without me?
Yeah.
Okay, so now we know that the z-score is 0.468. So this is just now math magic happening.
Right.
I'm going to take the sigma and bring it over, and I'm going to have 2 equations with 2 unknowns. I'm going to put one on top of the other, subtract them down to get rid of the mu, and then you're going to solve for sigma and then go back and solve for mu. Do you see the difference between the 2 types of problems? A lot of times they'll give you both on their stats exam. Okay? Does that make sense to everybody? Okay, so let me find another one. And guys, the place I found these are on 8mundo.com. You guys, I've given you that before. If you go and you can find, let's go to the next one, which is May, June 2000. paper 62. Okay, that's the answer scheme. See if there's any that look like what we're supposed to be doing. I think at this point we can find them. Haven't seen one yet. Got nothing.
Well, they just.
There's a normal. How do I know?
Because of the bell curve.
Because I see this as well. Normal, right? So it's number 7. Do you guys remember the number? 62, May, June 2014.
Yep.
So I'm going to come back to my teaching site that I have access to, and it's May, June 2014. Of course. There's also a student section on this CIE website that you can access papers.
Oh.
Okay. So, and it's not a whole lot of papers, not as many as I can access, but,
It's 62.
oh, darn it. We said number 7?
Yes.
There it is. Let's see how it looks. So the time Rafa spends on his homework each day in term time has a normal distribution, okay, with mean of 1.9 and standard deviation of sigma hours. On 80% of these days, he spends more than 1.35 hours on his homework. Okay? Okay, so do we want to turn on the light and try it without looking at the answers first?
Yeah.
Okay, so I would set it up first with my little, you got it, thank you. So I would set it up first with our little formulas that we know. Okay, talk to each other, kind of work ourselves through it. Okay, so the first one is to find,
Hey, I did that.
did you?
Not all of it, but I got some of it.
Did I not do that? I did that.
Oh, I did that.
Okay, did you do it? Like, did you get .653?
Oh,
yes.
No, I didn't get that.
I just
part.
set it
I
all
got
up.
to
Did
the
get that.
P. I got points.
I got-
I didn't get the free part because I didn't do them.
Oh, wait, so
Oh,
where,
I forgot to convert it to the one.
okay, did we understand, right now it's 80%?
Yes.
Right,
Uh-huh.
and we had to find the, to the right?
20, yeah.
Right, so what did we go about doing to do that? Okay,
How did you know it's the so I don't like the 8-4 2 part. How do you get the 2 part? That's what I don't get. I get the 4.
It's the top number.
it is the top number, isn't it?
Whatever up here, depending on what you need here. So for this one, was it 0.84, right? This one is
85. Okay, that makes sense. I read it the opposite way. Okay, we're good.
You I almost did that.
Okay, so, did everybody get this written down?
Yes.
I got .83. So, yeah, I'm not sure where that's from.
You got what?
So where is that coming from?
Okay, will you explain that, like you just did to her up here?
Yeah.
Maybe on here? Right up there. See if you can see it. Is it coming out better? Can you see it?
It's the lights on the all.
Lights.
So what, you want me to explain how you get the final number?
Yeah.
What is it in this case? It's
842.
842.
Okay.
Alright, so you want to find the closest one that you have without going over, which in this case is here, right?
Yeah.
Because you're looking for 80% or 0.8.
Yeah.
So it's the closest you can go without going over. And now, how many more do you need? So it's 0.84. And then how many
Right.
more do you need to get that to be exactly what you want? You want 0.8. That's 0.7995. You need 5 more, right? So you go over here to this 5. So if you add 5 to it, because it says add, if you add 5, you get what you want. Go up to the top, and it's a 2.
Did that make sense?
.842.
Yes.
So what if we didn't put the 2?
You kind of sort of have to. You try to get 3 decimals in. Okay, So let's get one more light back going. All right, so is everybody cool with that? Okay, yes.
What did you point 842?
Oh, that's what he just explained. Did you hear him? Were you there?
Yeah.
You sleeping?
You take the number, okay, you look at the chart, you find the number closest to the building usually. And then you take the first like number by the decimal is the number from the right, and then the second number is the number from the top. And then you take whatever the difference is between the number that you have and the number that you found. And you find it on your second chart, and then you add that to give you the
Are we good?
I'll show you.
Okay, cool, thank you. Okay, so now, does everybody have at this point, this written down? So we went from X's to Z's, right? Everybody cool with that?
Yeah.
So now, where does this come from? Well, this is our little formula. This is our X minus our mu. How do we know mu? It's given, right?
Yes.
Divided by what we don't know, which is sigma. So then we start to solve for sigma. Bring it
Yeah.
up here, right? And why is it negative?
Because it's used to be
Because it's less than the mean.
You have to be less than it, right? So it's behind the mean,
Right.
and you have to do the negative of it because it's in that. It's over here on that side. Remember, our standard deviation goes -1, -2, -3. Okay, so here we are, and there's your answer. Is everybody cool with that? Okay.
Yeah, but hey,
Go ahead.
so did you just like multiply the, how do you do that? How do you do that? Multiply sigma to the, okay.
Yeah, you multiply this guy up here, right? You actually subtract that out, get a number, and then divide by that.
Okay.
Is that what he told you?
No, I did
Oh.
that and he told me,
Oh, okay, gotcha. All right, are we cool? So, what did the second question ask?
binary resolution. I was the one who first question.
oh, I didn't
It's a PDF.
Oh, I got it. I don't have enough things open.
There it is.
All right. So ready? Okay. I'm ready. You guys are not going to understand this, and I'm going to be like. So, find the probability that on a randomly chosen day in term time, whatever that meant up here, okay, Rafa spends less than 2 hours on his homework. What? Less than 2 hours a day? No, I'm just kidding.
Isn't that all?
Okay, so find the probability that he spends less than 2 hours.
Plug it into the formula.
Okay, so give it a try. Less than 2 hours. P of X is less than 2.
Oh, wait, we're doing part II?
Yes.
Okay, I have a question.
Yeah.
It never mentions that he spends more than 2 hours. Like everything that is mentioned in the problem is less than 2 hours already.
Well, again, but there.
So is this just like another scenario? Okay.
How'd we do? Z is X is less than